All right, let's jump into another deep dive. This time, it's all about Terraform. And we've got some really practical questions and answers to unpack.
Yeah, should be a good one.
Definitely. So whether you're, thinking about an interview, maybe you want to level up your Terraform skills, or you're just into infrastructure as code, this one's for you.
Absolutely.
We'll be looking at things like, secrets management, what the heck Terraform init actually does, and how Terraform just gets resource dependencies, all that good stuff.
The source material we've got, it's called Terraform Interview Questions 1115. And I think what's interesting is that it gets into some real world stuff. It's not just, surface level. It's the kind of things that you'd run into when you're actually using Terraform day to day.
Yeah, for sure. So let's just jump right in.
Okay.
We're starting with variables and outputs.
All right.
Now, variables, think of them like ingredients in your recipe.
Okay.
You can define these in a few ways.
Yeah.
Environment variables, command line flags, you can use files. The cool thing about variables is they let you make your Terraform code reusable. Right? It's not just a fixed set of instructions.
Yeah.
You can kind of adapt it depending on the environment or the resources that you need.
And then outputs are like the finished dish, right? It's how you expose values from your Terraform code that you can then use in other parts of your infrastructure.
Oh.
So for example, let's say you're creating an AWS instance with Terraform.
Right.
You can use an output variable, maybe we'll call it instance heap, to grab that public IP address of that instance.
Right.
Then you can reference that IP address somewhere else, like in a script that configures your firewall.
Oh, that's cool.
It's all about making those different parts of your infrastructure work together.
I like that. Yeah, Terraform's like thinking ahead for you.
Definitely.
And speaking of thinking ahead, let's talk about keeping things secure, because when you're dealing with infrastructure, there's always going to be sensitive information that you need to protect.
100%, yeah. This is where secrets management comes in. And the golden rule is never, ever hard code secrets, like passwords or anything like that, directly into your Terraform code.
Right, yeah. Like leaving your house key under the welcome mat. Bad idea.
Exactly, yeah. No, that's a terrible idea. Thankfully, Terraform gives you some ways to handle secrets safely. You can mark variables as, sensitive, so the values aren't shown in logs or output. You can use environment variables, or you could prompt users for input during runtime.
Okay.
But for a really solid solution, you want to use a dedicated tool, something like HashiCorp Vault.
Now, Vault, that's interesting, right? Because it's not just a digital lockbox.
Right.
It can do things like automatically rotate secrets, which is great from a security standpoint.
Absolutely.
And our document actually has an example of using Vault to go and fetch a password. The key being that the password isn't actually stored in the code itself.
Yeah.
It's retrieved securely when it's needed.
That dynamic approach is way more secure than having static secrets just sitting in your code. Think of it like, having a security guard who personally delivers that information only when it's needed.
I like that analogy. Yeah, it's like on-demand security.
Exactly.
Okay. So, moving on, let's talk about a command that I think can sometimes feel a bit like magic, and that's Terraform init.
Oh yeah, Terraform init. That's a good one.
Everyone who uses Terraform knows this command.
Mm-hmm.
But seriously, what's it actually doing?
Okay, so think of Terraform init as like setting the stage for your Terraform project.
Okay.
So it's the first thing you do when you set up a new Terraform configuration.
Right.
It handles a few essential tasks.
All right.
First up, it downloads and installs any providers that you need.
Okay.
And providers, these are basically plugins that allow Terraform to interact with different platforms. AWS, Azure, Google Cloud, all that.
So if I'm working with AWS, Terraform init is making sure I've got the right tools to talk to AWS.
Exactly.
Gotcha.
Next, it sets up the back end for state storage.
Oh, okay. Now, this is where Terraform keeps track of your infrastructure, right? What resources you've created and their current state.
Mm-hmm.
Think of it like the memory of your infrastructure. It's absolutely vital for Terraform to work.
So Terraform init, it's like making sure you have all the right ingredients and equipment before you start cooking.
Yeah.
You're not going to try and bake a cake without an oven.
Exactly. And finally, Terraform init, it's going to install any modules that you're using. Now, modules, they're like pre-built components for your infrastructure. We'll talk more about modules later.
Yeah, that's a whole other deep dive.
Exactly. But they can save you a ton of time and effort.
Okay, so just to recap, you run Terraform init when you're setting up a new Terraform config.
Right.
You're adding or changing providers modules.
Yep.
Or if you're cloning a repository.
Absolutely.
Okay, cool. Now for something I find super cool, Terraform's ability to just manage resource dependencies. It's like Terraform has a built-in project manager, and it knows what needs to happen first. It's a really crucial feature, especially when you're dealing with complex infrastructure where resources depend on each other. Terraform has two main mechanisms for handling this: implicit and explicit dependencies. Now, implicit dependencies, this is where Terraform really shines.
Okay.
It analyzes the relationships between your resources, and it figures out the order of operations automatically.
Oh, wow.
So, for example, if your AWS instance configuration, it references the ID of a subnet, Terraform knows it has to create the subnet before it launches the instance.
So it's like knowing that you need to build the foundation of a house before you put on the roof.
Exactly.
That's really impressive. Saves you a lot of headaches trying to figure that out manually. But what about situations where maybe Terraform can't quite figure out those dependencies on its own?
Yeah, so that's where explicit dependencies come in.
Okay.
You use the dependent meta argument to tell Terraform, hey, this resource specifically depends on that other one. So it's like giving Terraform a little nudge.
It's like saying, hey, Terraform, I know you're smart, but can you just double check that this is done before you move on?
Exactly, just to be safe.
Right, exactly. All right, on to another important concept, remote state.
Yes.
Now, this is crucial when you're working in a team or when you need to make sure your Terraform state files are secure.
Definitely.
So what's cool about remote state is that it lets you store your state file, which is basically that record of your infrastructure's current state.
Right.
You can store it in a shared location.
Right.
So everyone on the team can see the same information and they can work together. It also adds a layer of security because you can control who have access to that shared location.
Think of it like having a shared whiteboard where everyone can see the progress and contribute without, stepping on each other's toes.
I like that, yeah. Collaboration, but safely.
Exactly.
So how does remote state actually work in practice?
Okay, well, the document uses AWS S3 as an example. But you can use other backends, too. You can use Azure Blob Storage or Terraform Cloud.
Okay.
The S3 example shows how you would set up Terraform to store the state file in an S3 bucket. And what I find really interesting here is the security features. So you can enable encryption to protect your state file while it's sitting in S3. And you can use DynamoDB locking to prevent conflicts when you've got multiple people trying to make changes at the same time.
So it's not just about storing the state remotely, it's about doing it securely and in a way that makes collaboration easier.
Absolutely.
Which makes total sense when you've got teams working on big, complex projects.
Definitely.
Okay, let's shift gears for a bit and talk about data sources. Now, data sources, these are a great way to tap into information that already exists, so you don't have to duplicate it.
Absolutely. Data sources allow you to pull information about existing resources, whether they were created with Terraform or not. It's like having a research assistant that can quickly gather the information you need from different sources.
I like that analogy. Yeah, it's better than trying to track down that info yourself. So our document uses the AWS Asami data source as an example. Can you walk us through that?
Okay, so let's say you want to launch an EC2 instance using a specific AMI. Now, instead of hard-coding that AMI ID in your Terraform code, you can use the Asami data source to dynamically fetch the ID of the AMI that you actually want to use.
Oh, that makes sense. So it's like having a reference library where you can look up the exact specs of a component that you need instead of relying on your memory or some outdated notes.
Exactly.
Yeah, data sources, they seem like they could be a real time saver.
Definitely.
All right, let's talk about planning and applying changes in Terraform.
Okay.
Because this is key, right? This two-step process, it helps you avoid breaking things.
Absolutely. So the two commands you'll use are Terraform plan and Terraform apply. Terraform plan is like a sneak peek, a preview of the changes that Terraform is going to make to your infrastructure.
Oh, okay.
So it analyzes your code, compares it to the current state of your infrastructure, and then it produces a detailed plan of exactly what actions it's going to take.
So it's like having a dress rehearsal before the main event.
Exactly, yeah.
You can see what's going to happen and make sure everything looks good before you actually make the changes.
Precisely. It's a really important step for reviewing and approving changes, especially, when you're dealing with production environments. Once you're happy with that plan, then you run Terraform apply. And that's where the rubber meets the road. Terraform goes out and it creates, modifies, or destroys resources based on your plan.
Got it. So Terraform plan is the blueprint, and Terraform apply is the construction crew.
I like that, yeah. That's a good analogy.
Okay, last but not least, let's talk about creating multiple resources with Terraform. You know, those times when you need to spin up like a bunch of web servers or a cluster of databases,
Right.
you don't want to have to create each one manually.
Hmm.
So how does Terraform help you with that?
So Terraform gives you two main ways to do this: count and for each. Count is the simpler one. You use it when you need a fixed number of instances, all with the same configuration.
Okay.
Like if you need 3 web servers, you can use count to create those 3 web servers all at once.
So it's like ordering 3 pizzas with the exact same topping.
Oh, exactly. Yeah.
But count can get a bit limiting if you need more flexibility. Like what if you want to create instances with different configurations based on maybe a list of server names or some other external data?
Right.
What do you do then?
That's where for each comes in.
Okay.
For each is more powerful and it's more versatile. You can iterate over a collection of items, like a list or a map, and create a resource for each item in that collection. And you can customize the configuration of each resource based on the data from the corresponding item.
Right. Our document doesn't get into the specifics of for each too much,
Yeah.
but it's clear that it's a more advanced tool for creating those multiple resources. I can already see how you could do some cool stuff with that.
Oh, yeah, for sure.
Maybe creating, a series of VMs, each with a slightly different configuration based on its role in the cluster,
Mhm.
or setting up a load balancer with a dynamic set of backend servers. There's a lot of possibilities there.
Absolutely. There's a ton of potential there. And for each really shows how elegant and powerful Terraform can be. You can create really complex and dynamic infrastructure with just a few lines of code.
That's amazing. But don't worry, if you're not quite ready for each, we'll definitely be diving into that more in future deep dives. And you can always start with count for those simpler scenarios. For now, the key takeaway is that Terraform gives you the tools to create those multiple resources efficiently and in a way that makes sense.
Absolutely. It's about picking the right tool for the job.
Exactly. So much good stuff in this one. I'm excited to keep going.
Me too. Let's take a break and come back for more Terraform fun.
Back again for more Terraform.
I feel like I'm already leveling up my Terraform game just from that first part. We talked about variables and outputs, how to handle secrets safely, that super important Terraform init command, and even how Terraform handles those resource dependencies. Yeah, and remember we only just touched on data sources and that whole world of modules. It's fascinating to me how all these concepts, they work together. It creates this powerful ecosystem for managing your infrastructure. It's not just about writing the code, it's about having a system, a way of thinking about infrastructure that's flexible and powerful.
Okay, you've definitely piqued my interest about modules.
Mhm.
I get that they're like reusable building blocks, but how do they actually work? Can you give me like a concrete example?
Sure. So let's imagine you're working on a project where you need a pretty standard web server setup. You need a virtual machine, you need a web server like Nginx or Apache, and maybe a load balancer to distribute traffic. Now, instead of writing all that Terraform code for those components from scratch every single time, you could create a module that we'll call web server
Oh,
that
wow.
encapsulates all that configuration.
So the module would have all the Terraform code to define those resources,
Mhm.
like the VM, the web server, the load balancer.
Exactly. And here's where it gets really cool. You can actually parameterize that module, meaning you can define variables that let you customize how it behaves. So you could have variables for things like the type of virtual machine, what web server software you want to install, how many instances you need, and all that.
Ah, so I see. So when I use the module, I can pass in different values for those variables and basically create different variations of that web server setup. So it's like a template.
Precisely. And modules can get even more sophisticated than that. They can have outputs, which expose values from the resources they create. You can use those in other parts of your Terraform code. You can even have modules that depend on other modules. It creates this whole hierarchy of reusable components.
So it sounds like modules are the key to building Terraform code that's really scalable and maintainable, right?
They really are, yeah. If you're serious about using Terraform, you have to learn to use modules effectively.
Okay. And you mentioned the Terraform registry before. Is that where I'd find these pre-built modules?
Yes, exactly. The Terraform registry is like a giant library of modules that have been created and shared by the Terraform community. You can search for modules by name, by category. You can even search by the provider that they're designed for. It's an amazing resource for getting started with modules and just seeing how other people are using them to solve real-world problems.
I'm definitely going to check that out after this. Sounds like a great resource.
Yeah.
Now let's go back to something we talked about a bit earlier. Can you talk a bit more about those security features with remote state management. You mentioned encryption and DynamoDB locking, and I just want to make sure I understand how those actually work.
Sure. So let's say you're storing your Terraform state file in an AWS S3 bucket. Now, by default, that state file is stored unencrypted, meaning anyone who has access to that S3 bucket can read what's in it, which is, not ideal if your state file has any sensitive information.
Right, yeah. That's like leaving your diary open on your desk for anyone to read.
Exactly. And that's where encryption comes in. You can tell Terraform to encrypt your state file using a key that's managed by AWS Key Management Service, or KMS. This adds a really strong layer of security because only authorized users who have access to that encryption key can decrypt and read that file.
So it's like putting a lock on your diary,
Yeah.
and you only give the key to people you trust.
Exactly.
Okay, that makes sense.
Yeah.
What about DynamoDB locking? Why is that important?
Okay, so DynamoDB locking is all about preventing conflicts when multiple people are trying to modify that state file at the same time.
Oh, okay.
So imagine 2 people on your team are both working on a Terraform project that uses the same remote state file. If they both try to run Terraform apply at the same time, they could end up overwriting each other's changes.
Oh, yeah, that could be bad.
It can get messy. You can end up with inconsistencies, errors, all sorts of problems. But when you configure remote state with DynamoDB locking, what happens is Terraform actually creates a lock in a DynamoDB table before it makes any changes to that state file. Now, if someone else tries to acquire a lock while it's already held by another user, Terraform will just wait until that lock is released.
So it's like a virtual waiting room that makes sure only one person can check out the state file at a time.
Exactly. Yeah, I like that analogy.
So it keeps things organized, and it prevents those accidental overwrites and conflicts.
Exactly. It's a super important feature for teams that are working together on infrastructure. It makes sure that changes are applied in a consistent way and helps to avoid those problems that could break things.
Yes, speaking of breaking things, I want to come back to those commands, Terraform plan and Terraform apply. We talked about them before, kind of like a dress rehearsal and the main event. Could you go a bit deeper into why that two-step process is so important for, avoiding those oops moments?
Sure. I think the key benefit of Terraform plan is that it gives you a chance to review and approve the changes that Terraform is proposing before they're actually applied.
Right.
And it's not just about catching errors, it's also about understanding the full impact of your changes. Terraform plan, it's going to show you exactly which resources will be created, modified, or even destroyed. It even gives you a diff of the changes that'll be made to existing resources.
So it's like having a crystal ball that shows you the future of your infrastructure.
Exactly.
You can examine the plan, talk about it with your team, and make sure everyone's on the same page before you make those changes permanent.
Precisely. And here's a tip. Don't just glance at the output of Terraform plan. Take your time. Really try to understand what it's telling you. Pay attention to the resource types. Look at the attributes that are being changed. Watch out for any warnings or errors that are reported. The more you understand the plan, the more confident you'll feel when you actually run Terraform apply.
Terraform plan, it's your superpower for preventing infrastructure chaos.
I'd say so, yeah. It's such a simple command, but it can save you so much time and effort and stress, and it's a core part of what makes Terraform such a powerful tool.
But even with Terraform plan, you've got to remember to follow those best practices. Things like version control, testing, collaboration, all of those things are important for minimizing the risk of making mistakes.
Definitely, yeah. Those are crucial.
It's clear that Terraform, it's not just about writing the code. It's about adopting a mindset of careful planning, taking the time to review things, and continuously improving how you work. It's about making sure those infrastructure changes are treated with the same level of care and detail as any other part of your software development process.
That's a really good point. I think that's one of the reasons why Terraform has become so popular. It's not just a tool, it's a philosophy. It's a way of thinking about infrastructure that helps teams move faster, work together more efficiently, and ultimately build more reliable systems.
Okay, before we wrap up this part, can we go back to data sources again? I think they have a lot of potential, but I'm still not totally clear on all the ways you can use them.
Okay, sure. Let's dig a little deeper into data sources. Remember, they're like research assistants that fetch information about existing resources. And this can be really handy in a lot of different situations.
Okay, give me some real-world examples. I'm all about practical application.
Okay, sure. Let's say you need to set up a firewall rule that allows traffic from a specific IP address range. Now, instead of hard coding that IP range in your Terraform code, you could use a data source to dynamically fetch the IP range of, let's say, an existing AWS VPC or an Azure virtual network.
Okay.
This makes your code more flexible because if that IP range of that network changes in the future, your Terraform code will automatically pick up the new range. You don't have to manually update it.
Oh, that's smart. So it's not just about fetching information, it's about dynamically adapting to changes in your environment.
Exactly.
What else can you do?
Another example. Let's say you're deploying an application that needs to connect to an existing database. Now you can use the data source to go and grab the connection details for that database, things like the host name, the port, the username, the password. And that way you don't have to hard code those sensitive credentials directly into your Terraform code, which is a huge plus for security.
Right. And that ties in with what we were talking about before with secrets management. Keep that sensitive information out of your code and fetch it securely when you need it. Data sources sound like a really good tool for that.
They are, yeah. And you can use them for way more than just fetching basic information. You can query complex data structures. You can filter results based on certain criteria. You can even do calculations on the data that you retrieve. They really open up a lot of possibilities when it comes to managing infrastructure as code.
I'm starting to see how data sources could be used to create infrastructure that's dynamic and intelligent, right?
Right.
It's like giving your Terraform code access to all this information that it can use to make better decisions.
Exactly. And the more you learn about data sources, the more creative ways you'll find to use them. You can simplify your code, you can improve its maintainability, you can make it more secure. There's a lot of potential there.
This has been so insightful. I feel so much more confident in my understanding of Terraform, and I'm ready to start putting some of these ideas into practice. But for now, let's take a break, and then in the last part, we'll dive into that for each thing a bit more compared to the count mechanism, and we'll talk about how to use those to efficiently manage multiple resources. All right, welcome back to the final stretch of our Terraform deep dive. We've covered so much ground already: variables, outputs, secrets management, modules, remote state data sources, and the importance of using Terraform plans so you don't accidentally break your infrastructure.
Yeah, it's been pretty amazing, right? And it's fascinating to me how all these different concepts actually fit together. They create this incredibly powerful and elegant framework for managing infrastructure as code. It's like we've been gathering all the tools and now we're finally ready to build something amazing.
I like that. Yeah, it feels like we've built a really solid foundation. And speaking of building in this final part, I want to get into, creating multiple resources with Terraform.
Yeah.
When you need to spin up like a whole fleet of servers or a cluster of databases. We talked about count and for each earlier, but I think I'm ready for the advanced level now.
Okay. I think you'll like this, especially if you work with, complex infrastructure where you need a lot of flexibility and control. So count is great for when you need a fixed number of identical resources. It's like ordering a bunch of pizzas, all with the same toppings, simple and efficient.
Right. Our document had that example with creating 3 identical AWS instances using count. It's easy to understand, but I'm guessing it could get a bit limiting if you need to do something more complex.
Yeah, you're right. Count works for basic scenarios, but what if you need to create resources with, different configurations based on external data? Like imagine you have a list of server names and each one needs different resources like CPU memory or disk space count. Can't handle that level of dynamic configuration.
Ah, okay. So that's where for each shines. It's like having a pizza chef who can make custom pizzas for everyone based on their own individual preferences.
Exactly. With for each, you can go through a collection of items. It could be a list or a map, and you create a resource for each item. And the key is you can customize each resource's configuration based on the data in that item.
Okay, can we walk through an example?
Yeah.
Let's say I have a list of server names,
Mhm.
and I need to create a virtual machine for each server, each with its own unique set of resources.
Sure. So in your Terraform code, you define a variable that holds a map of server names and their configurations, something like this.
Okay.
You would type in terraform.variableServers, type map object.name CPU number memory number.
So this defines a variable called servers, which is a map, and each item in that map is a server with its name, CPU, and memory needs.
Exactly. And then you would use a for each loop to go through this map and create a virtual machine resource for each server.
So the loop takes each server in the map and uses the server's name, CPU, and memory values to build each virtual machine.
Yep, that's the idea. And here's a simplified example of what that might look like in code Terraform. Resource, instance, server, for each, var.servers, Emmy venues, Emmy Halley week shell systine at PCDD of 0, instance type equals each dot value dot instance type, value tags, name each dot value dot name.
Wow, that's actually pretty easy to read. I see how for each makes creating multiple resources with dynamic configurations so simple. It's like a template that you can tweak for each instance.
Exactly. And for each is super powerful. It's not just for simple examples like this. You can use it to create really complex data structures and then loop through them to build very sophisticated infrastructure.
It's like a tool for managing complexity, right? Instead of trying to wrangle all those variations manually, you can let for each do all the work.
Precisely. And it's not just about efficiency, it also makes your code much easier to understand and maintain.
Which is so important when you're working on a team where everyone needs to be able to contribute to the code. I can see how getting good at for each can really take your Terraform skills up a notch.
Absolutely. It's one of those things that once you understand it, it opens up a ton of new possibilities. And it really fits with the whole philosophy of Terraform automation, efficiency, and elegance.
It's amazing to think about how far we've come. We started by looking at specific interview questions, and now we've explored this whole world of tools and concepts for managing infrastructure with Terraform.
And what's really cool is that we've only scratched the surface. The world of Terraform is always evolving with new features, and the community is constantly coming up with new tools and pushing the boundaries of what you can do with infrastructure as code.
It's exciting to think about everything people are building with Terraform, and I'm really motivated to keep learning more. Do you have any final advice for our listeners as they start their own Terraform journey?
Yeah, don't be afraid to experiment, share what you learn, collaborate with others, and most importantly, remember to have fun building cool things.
Well said. Thank you so much for taking this deep dive with me. It's been fantastic learning from you. And to everyone listening out there, keep learning, keep experimenting, and keep building amazing things with Terraform.